monopole antenna design for 1.8 GHz resonance frequency. After that we will shift this frequency to 1 GHz and similarly at 2 GHz and 2.4 GHz and so on. First take a cylinder for monopole antenna. Now here I will add some variables. Here PG is gap between the ground plane and monopole. Whose value is 1.116 millimeter. Press OK. Second is monopole radius value, whose value is similarly gap 1.116 millimeter. Next we will add monopole length, which is 36 millimeter. After this I will press OK, and from here this is we have a monopole arm. Now I am going to create a ground plane. Here I have added the variable parameter as a PL for ground plane, whose value is 110 millimeter. Press OK. Add the ground plane variable for both x-axis and y-axis and press OK. Here is our ground plane. Here you can see that the space between this ground plane and monopole, we will draw a port here. For designing port, first I will change axis to YZ, and then I will take the rectangle . Here you can see that the variable for y-axis has been added, which is MR as a monopole radius. In y-axis we will add multiple of 2 with monopole radius, and along z-axis the value of gap will be added. Press OK. Here you can see that this is we have a port. You can check the values of parameter from here, design properties. If you want to compare your values. Similarly, if you want to change any parameter values, you can change it from here in a design property. Now I am going to assign properties to a monopole. I am going to assign material as a PC, perfect conductor. Similarly, ground as a perfect conductor. And third, I am going to assign a lump port to this. As an excitation. The direction of this lump port should be toward the monopole. From here you can check the properties. Now I am going to add solution frequency, which is 1.8 gigahertz. I will select 15 number of passes. Next, an adding of frequency sweep from 0.9 to 2.7. I am going to add step size. Number of size is 100. Check for linear count. For 100 steps. I will same. Finally, I will create a radiation box. You must change the axis into XY axis. I will add the variable length for X axis as LX, 200 millimeter. Length for Y axis LY, similarly 200 millimeter, and similarly height is also 200 millimeter. Here I will add this variable as LX, LY, and height H. I will press OK. Now here you can see that this is a box. This is we have a monopole antenna. Now I will check the monopole antenna has been covered from all the sides. Assign this box as a radiation. Finally, check out the validation check. It is okay. Now I will simulate this. Now I will check the result. First is S11, return loss plot. This is we have return loss plot. Here I am going to add mark. Matching is not quite good, and we will see how we can improve this matching. Here you can see that the 1.8 gigahertz lies between this frequency band. Now we will check VSWR plot. And here we can add the mark. Here you can see that at this operating frequency point, the VSWR is less than 2, which is 1.5. For radiation behavior for this monopole, now let's check the animation of this monopole antenna. Similarly, we can check the radiation far field radiation pattern for this monopole antenna. Now in result, far field 3D polar plot. This is we have radiation pattern of this monopole antenna. Similarly, we can check the radiation pattern for gain of this antenna. Here you can see that it is radiating in the shape of 8.